Okay, so in this video we're going to go through section 2.6 in the textbook, and we're going to try and generate all of the tables and charts that are given therein. And so we want to use the West Roxborough housing data, and once you have JMP open, you can just follow along if you like. If you are not up to speed with JMP yet, make sure you go to the Getting Started video in the week 1 folder and work through all of those videos and examples and exercises that are given on the JMP web page. So first thing we need to do is open the West Roxborough housing data. You can see I've already got a couple of versions of that, but I'm going to show you how to open a new data set. So go to File and then Open, and wherever you have the data for this course stored, just navigate there and click the West Roxborough housing data and then say Open, and here's what you see. This matches up with the table 2.6 in the textbook. And the first thing we want to do is make a validation column. And so to do that, we're going to go to Columns, Modeling Utilities, Make Validation Column, and we'll put in 0.5, and we'll put in 0.5, and then purely random is what we're looking for. When you click on that, it's going to give us a validation 2 column. Now that's because the validation column is already there. This is the one that came with the data set, and if we want to match up with what's in the textbook, we're going to have to use this validation column instead of the validation 2, although we certainly could do everything with the second validation column, but I'm going to go ahead and delete this for now, and we'll just work with the one that comes with the book. If I wanted to get the same validation column here, I'd have to know what the random seed is that was used to generate this column, and I don't know what that is. It's not given in the textbook, and so we will not worry about that for now, although there is a way to specify what random seed you would like to start with. So we have a 50-50 split now with the data between the transition and the training and the validation set. And now we want to fit a linear model. So we're going to go to Analyze, Fit Model, and our Y variable, our response variable, is going to be total value. We're going to use validation for validation, and then we're going to use all of the variables, lot, square foot, through remodel, and put those in down here, and then we're going to click Run, and when this is run, we have the response total value, which is given here, and if I click on this little red triangle that points down and go over to Save Columns, I can put in the prediction formula, and then I'm going to put in the residuals. And now when I go back and look at the data, I will see that appended to this data set there are the predicted values and the residual values. So this matches up with figure number 2.10. And so if I want to further understand these, get summaries of these columns, at least of the residual total value, I'm going to go over here to Analyze and then Tabulate. And the variable that I want to use here, this is to get figure 2.11, is residual total value. So I'm going to pick that one, drag it over here, and then I want to get the mean. So I'm going to put the mean in here. That will replace the sum, and then I also want the min and the max. So if I put the min there and the max there, I will have the mean, the min, the max. You'll notice this is not the same as what I have for the table, figure 2.11, and that's because this is the mean, min, and max for all of the data, and I want it broken down by the validation and the training data. So I'm going to drag this validation right here and drop it right there. And now I get the training and the validation data, and that's going to be exactly what we have in table number, or rather figure number 2.11 on page 37 in the textbook. Okay, so when I say that I'm done, I now get this table, and I can use that however I like. And I'm not going to come back to that again, so now what I need to do is come back to our least squares fit, our least squares output, and if I scroll down I will see cross validation, which says what's the R squared, the root average square error, and the frequency count for the training set and the validation set. And this is what we have in figure 2.11. So the only thing that we're left with now is figure 2.13, which says what if we have new data that we want to score. And this is kind of the point of doing data mining, is you fit your models, you test them against validation data sets, and then you want to score new data or make predictions for new data. And so if we go back to our data set, which is here, and scroll down to the bottom, we can easily add new data. And if you look at the table, or the figure 213, you will see that they said the first new data point has 6,000 square foot lot, and the year that it was built was the year 2000, and the gross area is 2,500, and the living area is 2,000. Number of floors is 1, number of rooms is 6, number of bedrooms is 3, full baths is 2, half baths 0, kitchen 1, fireplace 0, remodel none, validation that should actually be 1 if we want to match up with what's in the text. So we'll put a 1 there, and it doesn't actually matter because either case we're going to get the same prediction, which is 354.89. Now notice the residual total value is not given to us. That's because in order to calculate the residual, we'd actually need to know the total value. So we don't have that because this is new data that we're scoring. We're trying to get an estimate for the value of the house, and this is saying for all those parameters we just put in, the value of the house should be expected to be $354,896. So we can do the same thing with the second data set. I won't make you watch me do that this time. I'll just put those in. And you can see when I do that, I get the same numbers in the table in the book, 479.7953. So this kind of gives you an idea of what it is we're going to be doing in this course, where we have a data set. We're going to clean up the data if it's not already, and then we're going to fit models, and then score data. So if you're not up to speed yet and didn't really follow exactly what I was doing here, just let this kind of be a carrot before the horse to help you understand, help you see where we're going with this stuff, but don't worry too much about the details yet. So make sure that you go and do the getting started things for JMP so that you can get up to speed quickly, and we'll see you in the next video.